All right, this is a video on the different ways to hook up batteries with series parallel and what the advantages and disadvantages of them are. This bank down here, they are all hooked in series. Nobody is in parallel. And we basically have, I think, 30 cells. So, now if we wanted to hook this bank of 30 cells up with this bank of 30 cells, our problem becomes that they will not all balance out evenly. And if we're charging and discharging, we have to either monitor every cell with a some kind of BMS on this and then some kind of BMS on this to protect all the cells. If we don't, if we just hook the most positive here and the most negative here up to our negative here and our positive there, and we start charging without a BMS, we could overcharge some of these cells. Now this is an example of a whole bunch of cells where I do have them all hooked. And if you look right here, you see that we got everybody lined up right along there and everybody lined up right along there. And that locks this whole group into, and we'd only really need one regulator, even though I got two on there. We'd only need one to watch this. Of course, two helps balance better. So, by locking those all in, and then we go over to the next cell, and then these are all locked in, and I don't have a jumper across here because it's here, but all these are locked in together, and they're all locked in together here, and then they go on to the next. So what you see is that keeps all this whole group at the same voltage in that group. That whole group is the same voltage. This whole group will be the same voltage. Every group will be the same voltage. And when you're charging, if the whole group gets to a high point, well, then your BMS should shut down the charger. So just to explain this a little further, I did this example right here where I wrote it out on the paper. This would be one way of hooking them up, where we hook them all, they're all hooked up in series. This is just 4 instead of 8. And the problem can be as you're charging here, let's say here's where our charging voltage goes in and our negative there. Let's say we charge all this up to 14 volts. That's what we're set at. Okay, well, hopefully the 14 volts will be divided among all these batteries, and each battery will be 3.5. That's what we would hope for. The problem is these batteries are not all exactly the same, and as we get close to the end of our charge, that's where the voltage goes up quite quickly. So if we were charging these and we were getting close to full charge, it's possible that this one would go up higher than 3.5. Let's say this is our smallest battery. He goes up to 3.7, or let's say he goes up to 4, just because it's an easy number to work with. All right, now we're 4 volts on this, so these guys here have all got to add up to 10. So they're all going to be 3.333, 3.333, and 3.333. They're not charged up. This guy is overcharged. Now, if we bring a wire from here over to here, like this, and here over to here, and here over to here, even if it isn't a big wire, it will help stabilize this whole thing. So this cell here we said was not, he's a weak cell. This guy will pick up that extra energy. The other thing is that we have our BMS across each one of these here. Well, now he's also balancing this battery over here. So by bringing these wires across each one, we help lock in the whole bank so that nobody can go over regulator voltage, even though we only have regulators on these 4.